Hi, welcome back. Okay, we are going to solve systems by graphing. We're going to solve systems by graphing. So folks, what you have to do is make sure you solve both equations and put them in slope-intercept form first, and then you are going to graph both lines and see if they intersect or if they're the parallel lines or if they are the same line twice. So for example, this one, we would graph this equation first. Remember, you always graph your y-intercept. So we would graph 3 on the y, and then we would rise and run your slope. So your slope is 1. So you would go up 1 over 1, plot your point, up 1 over 1. So that is this green line right here. Okay, then let's take our second line. We're going to graph our y-intercept. So our y-intercept is actually 0 because there isn't one right here. So you're going to graph 0 on the y, and then you're going to rise 1 and run 2 to the left. It's a negative slope. Or if it's a negative slope, go down 1 over 2. Down 1 over 2. This line should be going down from left to right. So now, folks, where these two lines intersect, because the slopes are different, I know these two lines are going to intersect and there's going to be one solution. If your lines are intersecting lines, you have to name the point where they intersect. So that is negative 2, 1. Negative 2, 1 is your solution. Again, if the lines intersect, you have to name the solution, the point where they intersect. Okay, so now let's take a look at this one. So I've solved both of my equations. They're both in slope-intercept form, and I'm noticing that it's the same line twice, same equation twice. So all you have to do is just graph it once. So you're going to graph your y-intercept first, remember, 3 on the y, and then you're going to rise 1 and run 1. Up 1 over 1, up 1 over 1. So there is my line, and I only have to do it once because this second line is the exact same thing. So I'll have the same line twice. Infinitely many solutions when you have the same line twice. Okay, and then I've solved both of these equations. They're in slope-intercept form, and I'm noticing that they have the exact same slope, but two different y-intercepts. So these are going to be parallel lines. They will never cross, so no solution. So again, remember, you graph your y-intercept first, so we would find 3 on the y and plot a point, and our slope is 1. So we would go up 1 over 1, up 1 over 1. So that is my first equation. Now I'm going to graph my second equation. Negative 2 is my y-intercept, so I'm going to make sure I graph negative 2 on the y-axis, and then again my same slope is 1. So I'm going to go up 1 over 1, up 1 over 1, rise 1, run 1. So notice these two lines are parallel lines. They have the same slope, but they're in two different spots because two different y-intercepts, so they will never cross, no solution. Okay, so let's just practice a few of those. So on this first one, these are not in slope-intercept form. So I'm going to rewrite this top equation, x plus 4y equals 8. Remember, the first thing you want to do is move the x term to the other side. So let's subtract that 1x and move it over. So I have 4y equals negative 1x, and then I have the plus 8. My slope is there, my y-intercept here, and then I divide everything by 4. Okay, so y equals negative 1/4 x. 8 divided by 4 is 2, plus 2. So now I need to do the exact same thing to this equation. This one is not in slope-intercept form either. So I'm going to subtract 3x from both sides, move the x term over, bring down what's left. 4y equals negative 3x, so the y-intercept is 0. I don't really need to put anything at the end. Now I'm going to divide by 4. So y equals negative 3/4 x. And again, the y-intercept is 0. Okay, so now that I have these solved, I am going to graph. So let's graph this line first. So graph the y-intercept first, which is 0. Plot 0. Now, you're going to, the slope is negative, so we're going to go down 3 over 4. Down 1, 2, 3, and run 1, 2, 3, 4. I went, excuse me, down 3, 1, 2, 3, and over 4, because that's my slope, down 3 over 4. So now, if I do that slope backwards, I can go up 3 and over 4 to the left. See, these points still line up. So, oops, that is my line. That's the line for that equation. Now, let's graph this second one. I'm going to graph my y-intercept of 2. And now it's a negative slope. So down 1 over 4. So down 1 over 1, 2, 3, 4. And now I need to do that slope backwards. So instead of going down 1, right 4, I'm going to go up 1, left 4. 1, 2, 3, 4. And there is where those two lines intersect. So when I draw my line, I know that my lines were going to intersect because my slopes were different, and now I just need to name that ordered pair. This is one solution, and the point where my two lines are intersecting is my solution, so I have to name it. -4, 3. -4, 3. Okay, let's try another one. So this one, we are going to rewrite this equation right here, 2x minus 3y equals 6. First thing you want to do is move the x term to the other side. So I have a -3y equals -2x plus 6. Divide by -3. So y equals, okay, 2 negatives equal a positive, 2/3 x. 1 negative equals a -2. Okay, so now I'm going to actually solve this one. So the first thing I'm going to do is subtract 4x from both sides, move the x term over. Okay, now I'm running out of room right here, so I'm just going to put this up here. I have a -6y. -6y equals that -4x plus 12. Now I'm going to divide everything by -6. So y equals, okay, 2 negatives equal a positive, and then 4, 6, these are both even, so let's cut those in half and get 2/3 x, positive. And then 12 divided by -6 is -2. Okay, so if you're looking at both of these equations, this is the same line twice. So I am writing infinitely many solutions, and now I'm graphing it. So I only have to graph this one time because it's the same line twice. So find -2 on the y, you graph your y-intercept first, and then we're going to rise 2 and run 3. Go up 2 and over 3. Okay, let's do one more. So let's take a look at this one down here. So we're going to put these in slope-intercept form. So on this top equation, x plus 2y equals 4, I'm going to subtract x and move it over that 1x. I have 2y equals a -1x plus 4, and then divide everything by 2. So y equals -1/2x plus 2. That's my answer for this one. So now I'm going to do the same thing here. I'm going to move the 4x to the other side. So I have 8y equals -4x plus 64. And then I'm going to divide everything by 8. So y equals, that is a -1/2, that reduces to -1/2x plus 8. Okay, I'm noticing that both of these have the exact same slope, but two different y-intercepts. So these are going to be parallel lines, and this is going to be no solution. So let's graph this. Let's graph 8 on the y. So 6, 7, 8. And then I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. Okay, and then let's graph 2 on the y. Graph your y-intercept first. And again, I'm going to go down 1 over 2. Down 1 over 2, down 1 over 2. So again, these are parallel lines, no solution. I hope that helps.